Hello friends, here in this video we are going to see a problem on development of a hexagonal prism. Here is the question. A hexagonal prism, side of base 40 mm, axis height 90 mm, has its two sides of base parallel to VP. A section plane cuts the prism such that the section plane passes through extreme left bottom corner to extreme right top corner of the prism. Show the development of lateral surface of half cut prism. Now this is the question in front of us. Whatever the conditions are given here, I'll explain them step by step. But before starting this, once we read the question, we are familiar with the type of solid, and that is hexagonal prism. So here I'll draw the diagram of that hexagonal prism and then explain the conditions step by step. So here is the diagram of the hexagonal prism. In this we have a hexagonal top, then hexagonal base. Then since it is hexagonal prism, it has 6 corners, and those 6 corners at the bottom are connected with the 6 corners at the top with the help of edges. Then because of the edges, since it is hexagonal prism, there will be 6 rectangular faces. So these are the rectangular faces which we have. And now, once we have understood the hexagonal prism, we can start with the question. Here it is given that a hexagonal prism, side of base 40 mm, axis height 90 mm, has its 2 sides of base parallel to VP. Now this condition I'll explain in the solution. So let us get started with the solution part. Now the side of the hexagonal prism is given as 40 mm. So for that, I'll draw the hexagon. Drawing a light line, then light after this light horizontal line, a light vertical line. Now as the side of the base is given as 40 mm, and when we are going to plot it here, it won't be fitting properly here. So here I'll take a scale in this problem. I'm assuming that scale as 1:2, that is drawing it with half scale. Now as the side of base of hexagon is 40 mm, so I'll assume that the side is now 20 mm. For that I will have to take the radius as 20. So here as the side of base is given as 40, I am taking it 20 because drawing it with half scale. So measuring the radius equal to 20 mm. Keeping that same distance in the compass, drawing a right circle. Now here the question is, hexagonal prism side of base 40 mm, axis height 90 mm, has its 2 sides of base parallel to VP. So I have to keep this prism in such a way that two of its sides are parallel to VP. It means this hexagonal prism will be visible, it will be kept in HP, because if the edges are parallel to VP, it will be visible in HP. So I have to keep this hexagonal prism on HP, that is also called as the ground. And when I will be keeping it on the ground, from the top we are going to see the hexagonal prism in such a way that two base edges or two base sides remain parallel to VP. So for that, so here I am making two base edges or base sides parallel to VP. Next, here as we see, I'll give it the notations. Now, this is the top view of the hexagonal prism. From this, I am going to plot the front view, and here if we see in the top view, edges 2, 3 and edges 5, 6 are parallel to VP. They are seen in HP. So projecting these points in the front view, now the height of the hexagonal prism is given. It is axis height is 90 mm. So the height of the hexagonal prism is 90, but as I am taking half scale here, so the height will be half of 90, that is 45 mm. Measuring 45. Two dash and 6 dash are at the same location, similarly 3 and 5, and here we have 4 dash similarly at the bottom, because there are two hexagonal faces, one at the top and other at the bottom, so giving the notations to both of them. Next, after completing this, that is drawing the top view and front view of the hexagonal prism, the next thing would be to locate the cutting plane. For that, the condition is given. A section plane cuts the prism such that the section plane passes through the extreme left bottom corner. So here I'll mark the extreme left bottom corner is 1 dash at the bottom, and to extreme right top corner of the prism, and the extreme top right corner of the prism is 4 dash. So these are the two corners through which the cutting plane is passed. Show the development of lateral surface of this half cut prism. So we have to draw the development for it. Now, as the cutting plane is passing through the bottom left, extreme left bottom corner and extreme right top corner, it means here I draw the cutting plane. Now this light line indicates the cutting plane, and as we know, when we are cutting this object, we have to remove some part of this hexagonal prism and retain some part. So which part is to be retained, that we have to decide, and for that observer is here at the top. So when the observer is at the top and this hexagonal prism is cut, then the portion which is close to the observer has to be removed, and the portion which is away from the observer, that is behind this cutting plane, it has to be retained, because when the section is cut, the cut section should be in front of or close to the observer. So I will be removing this top portion, so keeping it light and retaining the bottom portion, so I will make that dark. Next, I'll make this cutting plane dark. Cutting plane A dash. So when the cutting plane is cutting this hexagonal prism, then here all of the points we can see that all the edges are cut. It means when we are looking from top, then this on this complete hexagon there will be sectioning lines. So for that I'll make the outlines dark first. Next, here I'll have to draw the section lines, and those are inclined at 45 degree. This is the continuation of the problem.
This is the continuation of the problem.
So drawing those section lines. Then here as we see that the section plane is cutting the hexagonal prism at these locations. So I'll give the notation. Here it is cutting this corner
at 1 dash, so I'll call that as A dash.
Then it is cutting edges 2 and 6
at the same time. So where it is cutting 2,
B dash.
I'll say that is
where
B
it is
dash.
cutting 6, I'll say
Where it
that
is cutting 6, I'll say that is F dash.
Then for 3 and 5 where it is
Then
cutting
for 3 and 5 where it is
dash.
cutting 3, that
Where
is
it
C
cutting
dash.
5, that is E
Where it
dash.
is cutting 5, that is
At
E
last
dash.
where it is cutting this
At last where it is cutting
corner at 4
this
dash,
top corner
that
at
will be
4
D
dash, that will be D dash.
Now after marking these points,
Now
we
after
have to
marking
draw
these
the
points, we have to
development
draw
of
the
this
development
cut
of
hexagonal
this
prism.
cut hexagonal
So what
prism.
is that development?
So what is that
See, for
development?
we
See, for
have to
development,
open this solid.
we have to open this
And
solid.
opening means
And opening
here,
means
I'll start
here,
with the extreme left corner, that is
extreme left
for
corner,
these
that is
cut solids.
for these
I will
cut
be
solids.
opening them
I will be
from the
opening them
extreme left
from the
corner, that is
extreme
point
left
1.
corner, that is
So
point
when I
1.
will be opening
So
this,
when I will
as
be
we see
opening
here,
this,
there is a
as we see
hexagonal
here,
prism.
there is a
So it
hexagonal
has
prism.
6 edges.
So it has 6
So
edges.
these 6
So
edges
these
will be
6
forming
edges
6
will be
rectangular
forming
faces.
6
That
rectangular
means when we
faces.
open this
It
hexagonal
means when we
prism, we are
open
going
this
to get
hexagonal
six
prism, we
rectangular
are going to
faces.
get the 6
So that
rectangular
I am going
faces.
to plot it
So
here.
that I am going to plot it
So
here.
at first, I'll draw a light vertical line
parallel to it.
And then since there are 6 faces,
Each
phase has a dimension
and
of
each
20
phase has a
mm because
dimension of
I've
20
taken
mm because I've taken
so
half
it
scale
is
here.
having 6
So
faces
it is
means
having 6
the
faces
size,
means
total size
the total size will be
mm.
of
When I
120
open
mm.
this, so I'll
When I
measure
open
120.
this, so I'll measure 120.
mm. Dividing it into 6 parts.
Dividing it into 6 parts.
Then drawing light horizontal line. Projecting light vertical parallel lines. Next, after plotting it light, here I'll give the notation. As I have said, I have started opening it from point 1.
So here I'll get it as 1 dash, 2 dash, 3, 4,
6
5,
and again 1.
6 and again
Because we have
1.
to start from
Because
point
we
1.
have to start
So
from
1
point
to 2,
1.
2 to 3, 3
So
to
1 to
4,
2,
4 to
2
5,
to 3,
5
3
to
to
6,
4, 4 to
and then
5,
again
5
6
to
to
6,
1.
and then again 6 to 1. It means the
At
solid
the
should
end
close
at
the end where it started. So started at 1 and it will close even at 1.
At the bottom,
Similarly at the bottom,
1 dash, 2 dash,
1 dash, 2 dash,
4,
3,
5,
4,
6,
5,
and 1.
6 and 1.
Now after
Completing this development, it means I have opened this hexagonal prism in such a way that
it is not cut.
At first it is not cut. It is a complete
which I have
hexagonal prism
opened,
which I have
all
opened
its
and
rectangular
opened
faces,
all its rectangular
and then keeping
faces
it flat.
and then
So
keeping
here
it
I am
flat.
getting 6
So here I am getting
rectangular
6
faces.
rectangular
Because
faces
this being a hexagonal
because
prism.
this being a
And
hexagonal
the total
prism
length is
and the total length is
120
corresponding to
that is
120 mm.
one side
That is
multiplied by this
one
6
side multiplied by
rectangular
these
faces.
6 rectangular
now
faces.
I have to denote
Now I
these
have to denote
points A
these
dash up
points
to
A
D
dash
dash
up to
on this
D dash
development,
on this development,
because here the hexagonal prism has been cut.
hexagonal prism has
So
been
if I
cut.
see here,
So if I see here,
while plotting the points,
while plotting the
A
points,
dash is
A dash
at 1 dash at
is
the corner.
at 1 dash
So
at the
wherever I am
corner.
getting 1 dash
So
at the
wherever I am
corner,
getting 1 dash
and
at the
even 1
corner,
dash is here at the
and even
extreme
1 dash
corner,
is here at the
that is
extreme
going
corner,
to give me the point
that is
A
going
dash.
to give me the point A dash.
Then point B and F.
Then point B
I'll
and
say
F.
that where B is
I'll
cutting,
say that where
it
B is cutting,
point 2
it
dash
is
2
cutting
dash
point
and edge
2
here.
dash 2 dash
So
and edge
projecting
here.
it.
So projecting it.
So I'm projecting it light,
So I am projecting it light,
extending it,
extending
up to 6
it
dash.
up to 6 dash.
Now, where
Now,
it is cutting,
where it is
2
cutting,
dash 2 dash, that
2
will
dash
give me
2
the
dash,
point
that will give me the
B
point
dash.
B dash.
Next, where it is
Next,
cutting,
where it is
6
cutting,
dash 6 dash, that will give
6
me
dash
F
6 dash, that will give me F dash.
So F dash. Next,
So F dash.
C and E.
Next, C and
C
E.
is cutting edge 3
C
dash
is
3
cutting
dash.
edge
E is
3
cutting
dash
edge
3
5
dash.
dash
E
5
is
dash.
cutting edge 5 dash
So
5 dash.
projecting them
So projecting them
light. So here we have points.
So here we have points
C dash and
C dash
E dash.
and E dash.
Then at last, if we see here,
Then at last,
point
if
D
we
dash
see
is
here,
cutting corner
point
4
D dash is
so
cutting corner 4
is
dash. So corner 4 dash
exactly at the
is
center.
exactly at
So
the
that will
center.
give me D dash.
So that will give me D dash.
Next, since it is
Next,
a hexagonal
since
prism,
it is a hexagonal
that means
prism,
it doesn't have
that means
curved
it doesn't
surface
have
like cone or
curved
cylinder.
surface like cone
So
or
we are going
cylinder.
to join these
So
points
we are going
with the
to
help
join
of
these points with the help
lines
of
and
light
connecting
lines
them.
and
It will
connecting
be
them.
from A
It
dash
will
to
be
B dash,
from A dash to B dash,
then from B dash to C dash,
then from B dash to C dash,
C to D, and
C
in
to
order
D, and in
for the
order
remaining points.
for the remaining points.
And then these
And
corners
then
will be connected.
These
that is
corners
A
will be
dash to A
connected.
dash,
That is A dash to A dash,
where the solid will close.
where the solid will close.
So next, after
So
completing
next,
this,
after completing
light,
this,
I'll make it dark. so
light
that we
I'll
get the
make
true
it dark so
development.
that we get the true development.
Next, we
Next,
cannot leave this
we
development
cannot leave
as
this
it is because
development as it is
here the
because
hexagonal prism
here
has
the hexagonal
solid
prism
edges,
has solid
like
edges,
1 dash,
like 1
or
dash
either
1
we
dash,
can say 2 dash up
or
till
either
the
we
cut
can say
portion.
2 dash up till
So
the
these
cut
are the
portion.
solid edges.
So
we
these
need
are
to
the
connect
solid
2 dash
edges.
with
So
B
we need
dash,
to connect 2 dash with B dash,
3 dash with C
3
dash,
dash with C dash,
4 dash with 4 dash,
4 dash with 4 dash,
then 5 dash
then
with E dash,
5 dash with E dash,
then 6 dash
then
with F dash,
6 dash with F dash,
and the corners are being cut
and the
at
corners
A dash.
are being cut at
So
A dash.
in this way, the development
So in
of
this way, the development of the
like,
hexagonal prism will
like
look
for
like.
example, if I am
Like
going
for
to
example,
fold it
if I am
about
going to
its
fold it about
dark
its
edges,
dark edges,
and then turning it and
and then
joining
turning it and
A dash
joining
with
it
A dash, I am
A
going
dash
to get
with
this
A dash,
cut
I am going to
hexagonal
get this
prism.
cut
That is the
hexagonal
development
prism.
of this cut
That is the
hexagonal prism.
development of this cut
Next,
hexagonal
after
prism.
completing this, I'll give
Next,
the
after
dimensions
completing
to
this,
it.
I'll give the dimensions to it.
Twenty mm side,
20 mm side,
height I have taken it as
height I have taken it as
45 mm.
45 mm.
So here
So here
I'll say that
I'll say that
height is 45.
height is
And
45.
Here I am
And
getting the
then
total length.
Here
which
I
is
am getting the
120
total length,
mm.
which is 120
So
mm.
with this we
So
complete
with
the
this we complete the problem.